For our Watson capstone project, we were tasked by Lockheed Martin to create an electronic harness assembly system. An electronic harness assembly is a bundle of wires that can be used to provide interconnections between different electronics in an aircraft. Wiring harnesses can be rather complex, so it is often easier to prepare them on a flat surface before installing them into the final system. However, this is a fairly time-consuming process that requires a good amount of space for storing the old harness assembly setups.
So we designed our SmartPeg system to address some of the problems with current wiring harness manufacturing, and the motivation behind our solution was really driven by the requirements that Lockheed Martin had placed on us for the whole system. The main requirement that was placed on us were that the pegs needed to be modular and reusable. We developed a peg that could attach to any pegboard that has around a 1/10 of an inch hole size. The second most important requirement was probably that it needed to incorporate modern electronics. This was done by using an LED, microprocessor, and wireless module. The combination of these two technologies creates a nice, robust, and versatile system.
Our system alters the process for creating wiring harnesses. Let's walk through the system usage right now. After affixing the printed wire layout to the board, the user inserts the pegs at key locations. The user then launches the Graphical User Interface, or GUI. The user then adds a route and selects it by clicking on it. Pressing the button on the end of each peg adds it to the route. The user then presses the buttons for all pegs in the route to register it in the GUI. This process is repeated for the remaining routes. We accelerate this section for brevity. The user switches the system into routing mode and turns on the display functionality. Selecting the first route illuminates the associated pegs on the board, identifying the wire path. This is repeated for the remaining routes to build a complete wiring harness. After completing the wiring harness, the user turns off the display functionality to conserve power.
Our work as an engineering team didn't end with system design. Iterative processes on the hardware, software, and mechanical prototypes were used. These processes include PCB revisions, recoding, 3D printing, machining, physical testing, and finite element analysis. In the end, an optimal product was created. You simply have to keep pushing the boundaries until you end up with something extraordinary.